We are now ready to start the last group of problems on polar coordinates. So we are now ready for problem 24. That's where they give you a polar coordinate and then they give you a list of other polar coordinates and ask you which of these are the same. So the initial polar coordinate is 3 pi over 3. So once again, when you graph a polar coordinate, you go find your angle first. Pi over 3 is right here. And then you move a distance 3. I'll just say, so there's pi over 3 angle. We'll call that distance 3. Now, the easiest way is to go through these other points and see which ones are the same. So for instance, first one they say is 3 negative pi over 3. So negative pi over 3 is down here, and 3, we're down here. Definitely not the same point. Negative 3, negative 7 pi over 3. Now this negative 7 pi over 3 is really the same thing as negative pi over 3, because negative 2 pi is negative 6 pi over 3. So you go around the circle once, and you go back to negative pi over 3, but the negative 3 flips it over, so you end up here. Definitely not the same point. How about 3, 5 pi over 3? Well, 5 pi over 3 is right here, and then distance 3, we're back here. I mean, this is the point I'm looking at. So far, none of these have been the same. How about negative 3, 4 pi over 3? Negative 3, 4 pi over 3. 4 pi over 3 is right here. Negative 3 means the opposite direction, the distance of 3. Boom. Yes, we're at the same point. So negative 3, 4 pi over 3 is the same point. 3, 7 pi over 3. 7 pi over 3 is actually the same thing as pi over 3. So pi over 3, 3, that's definitely the same point. And the last one is negative 3, negative 2 pi over 3. So negative 2 pi over 3 is right here, but then a negative 3 flips it. So actually the last 3 they gave you were all the same points. 25 is the same kind of problem. The initial polar coordinate is 4 negative pi over 2. So negative pi over 2 is going straight down, and we'll just say 4. So we'll say it's right here. Distance of 4, angle, negative pi over 2. Now let's go through the list. The first one is 4 negative 9 pi over 2. Think about negative 9 pi over 2. 2 pi, or negative 2 pi, is negative 8 pi over 2. So it's really negative pi over 2 and 4. That definitely is the same. Negative 4, negative 3 pi over 2. Negative 3 pi over 2 is a positive y-axis, but negative 4 flips it down here. So that's the same point. How about negative 4 pi over 2? Pi over 2 is positive y-axis, but the negative 4 flips it down here. That's the same point. How about 4 and 3 pi over 2? 3 pi over 2 is a negative y-axis and distance 4. So far, all 4 of those are the same. How about 4 and 5 pi over 2? 5 pi over 2, well, 4 pi over 2 is 2 pi, so this is really the same as pi over 2. So pi over 2 is straight up, a distance of 4. That one's not the same. And then negative 4, negative pi over 2. So negative pi over 2 and negative 4 is also straight up. Looks like the first 4 are the same, but not the last 2. All right, now we have some problems. They're going back and forth between polar and rectangular coordinates, right? So rectangular coordinates are x and y, polar coordinates are r theta, and we want to go back and forth. So 26. A, start with a polar coordinate of 9 pi over 3. So there's r and there's theta. And we want to know what is that xy. Well, we have nice little formulas. X is r times cosine theta. Y is r times sine theta. Now, I think they want exact answers here. So r is 9. Cosine of pi over 3 is 1/2. Y, sine of pi over 3 is square root of 3 over 2. So it looks like 9/2 and 9 square root of 3 over 2. So the x is 9/2 and the y is 9 square root of 3 over 2. Now for B, they start with a negative 19, 2 pi over 3. So for x and y, once again, x is negative 19 times the cosine of 2 pi over 3, which is negative 1/2. So it's 19 over 2. So there's your x. And y is negative 19 times the sine of 2 pi over 3, square root of 3 over 2. So negative 19 square root of 3 over 2. So it's like 9 over, so there's that one. 27 is the same thing. Start out with polar coordinates and switch to rectangular. 6 negative pi over 4. So the x is going to be 6 times cosine of negative pi over 4. Well, cosine of negative pi over 4 is square root of 2 over 2. So it looks like it's 3 square root of 2. And the y is 6 times the sine of negative pi over 4. And that's going to be 6 times negative square root of 2 over 2. So it looks like it's negative 3 square root of 2. And then there's a part B for this one. The polar coordinate is -8, 19 pi over 6. Let's figure out what 19 pi over 6 is. 12 pi over 6 is 2 pi. So this is really the same thing as 7 pi over 6. So we can think of this as -8, 7 pi over 6. So now in x and y, x is -8 times the cosine of 7 pi over 6, which is -√3/2. So that's going to be 4 square root of 3. And y is -8 times the sine of 7 pi over 6, which is -1/2, which is going to be 4. So 4 square root of 3 and 4. Now the last two problems go the other way. We start with rectangular coordinates, and we have to come up with the polar coordinates. So for 28, rectangular coordinates are -1, -1. And we want to know what is it going to be in polar coordinates. This one, okay, so for the r, right, you sort of take the x part, you square it, plus the y part, you square it, square root of the whole thing. So 1 squared plus 1 squared. This is square root of 2. So square root of 2. Now the angle is always the tricky thing. So this is where a lot of times we have to see where our point is. -1, -1. We're really right here. So this is going to be our angle. So it's inverse tangent of y over x. -1 over -1. Inverse tangent of 1. So we're looking for the angle where the tangent is 1. Now, inverse tangent has to be over here. Since tangent is sine over cosine, we know that's going to be where the sine and the cosine are the same. And that's going to happen at pi over 4. Of course, we know our point is here. We know the reference angle, therefore our angle is going to be 5 pi over 4. So to get in the right quadrant, I had to make it 5 pi over 4. And then B, -3 square root of 3 minus 3, that's the x and the y. So r and theta are 3 square root of 3 squared plus 3 squared. So that's 927 square root of 36. Looks like it's 6. Now the angle is always the tricky part. -3 over -3 square root of 3. Now, if you think about that as sine over cosine, what's an angle where sine over cosine is 1 over square root of 3? That's going to be where you have the 1/2 over the square root of 3 over 2. Where does this occur? Where is the sine 1/2 and the cosine square root of 3 over 2? Well, that happens at pi, pi over 6. So this is theoretically pi over 6, but is that really our angle? The x and the y are both negative. So I'm really down in here someplace. So what I've done, I've said this is my reference angle, pi over 6. That means the actual angle is going to be pi plus pi over 6. It's going to be 7 pi over 6. Once again, to put it in the third quadrant. And the last one, 29. X and y, 4 square root of 3, 4. So what is that as a polar coordinate? The r is always the easy part. 4 square root of 3 squared plus 4 squared. This is 16 times 3, which is 48, plus 16. It's actually 64. So the r is 8. Now, tricky part is the angle, 4 over 4 square root of 3. I think we just had a problem like this. 1 over square root of 3. It's pi over 6. Now this one, since this is in the first quadrant, it's actually going to be 8 pi over 6. And part B, the last problem. The x and the y. 3 negative 3 r 3 squared plus 3 squared. Square root of 18, which is 9 square root of 2. 3 square root of 2. Theta, inverse tangent of negative 3 over 3. Inverse tangent of negative 1. So basically, where is the sine and the cosine the same number but opposite signs? Looks like we're in the fourth quadrant. So you know it's going to be 7 pi over 4. All right, so that's polar coordinates.